Hi everyone, this is Asma Mushtaq from the EEVIBES, and in this tutorial I'm going to guide you about the PICKit 3 programmer or the debugger. This is basically a simple low-cost in-circuit debugger that is controlled by a PC running MPLAB IDE software or the Windows platform. This programmer or the debugger is used for importing the hex file from your computer system to this PIC microcontroller device. By the way, you can see a development board right here as well, which is associated with the PICK18F4550 microcontroller. Alright, and we will test it in the coming video. Fine. So basically this PICKit 3 programmer or the debugger system has the several features in it, which include the free USB support using the Windows standard drivers. It performs the real-time execution, processors run at the maximum speed, and the voltage that can be applied from this is from 1.8 to 5 volts. Fine. Similarly, it can perform the read-write program and the data memory of the microcontrollers, and also it can be used for raising the memory of the microcontroller. Fine. Now let's have a look at each part of it in detail. So the first thing that you will notice is this hook. This is basically the lanyard connection, and we can use it for placing a strap or a cord to provide the ease in carrying this PICKit 3. Fine. Then you can see a USB connection port which will be used for connecting this debugger or programmer with your computer system. Fine. Then you can see here is an arrow indicator which is known as the pin 1 marker. This pin 1 marker is actually represents the master clear input, and this master clear input pin is actually active low pin. Fine. And this will be connected with the MCLR pin of PIC microcontroller. The purpose of this MCLR pin or the master clear pin is used for resetting the microcontroller. So whenever we will apply a low voltage, it will be activated and the microcontroller will go into the reset mode, which is actually not preferable. We usually provide the high voltage to it and deactivate this pin. Fine. Then you can see here the program connector. This program connector is actually a 6-pin connector, and starting from the 1 pin which is the master clear pin, then we have other pins that are, so the second pin is the VDD pin, which is the power pin. Fine. You can power up the PIC microcontroller with this pin. Then the third pin is the VSS, which is usually connected with the ground of the PIC microcontroller. And by the way, the 11th pin is actually the VDD pin. So 11th pin of the PIC microcontroller will be connected with the second pin of this programmer or debugger. Similarly, the third pin of this debugger will be connected to the 12th pin of the PIC microcontroller, alright, which is actually the ground pin. Then the 4th and 5th pin are basically the programming pins. Fine. They are known as the PGC and PGD. So for programming for the clock and programming for the data. These two pins will be connected with the 39 and 49 pins of the PIC microcontrollers respectively. Okay. Sorry, 40 pin of the PIC microcontroller. Alright, and this is basically interrupt on change pin and in circuit debugger basically. The last pin of this debugger is actually the LVP pin, and it is not connected, so it is basically not used for our programming purposes. Now let's see how we can connect this debugger with the with the development board and with our PC. Fine. So first of all, you can see here is the knob, and I will connect it with this port. Then what I need to do, This is the USB connector that will be connected with the USB port of your computer system. Fine. So once you connect this USB port with the computer system, you can see here the status LEDs are turned on. So basically there are three types of the LEDs present on this board. So the power light green indicates that the PICKit 3 is powered up via the USB port. Fine. While the active pin, if it is blue, it indicates that the PICKit 3 is connected to the PC and the communication link is active. Means your system is turned on as well and the connection has been established. Fine. While this status pin or LED, if it is blue, it's okay. It means your PICKit 3 programmer is all fine. But if it is red, it means there is some problem with the PICKit 3 burner or the programmer. While this push button switch is used for resetting the controller or for resetting this programmer or the debugger as well. Now let's see how we can actually connect this PICKit 3 programmer with the development board. So I need to make sure to connect it properly. Fine. So here MCLR master clear pin will be connected with the master clear pin of the PIC microcontroller. And here what I have done, I have basically now connected this programmer with the development board like that. And now I will test a program where I will blink the LEDs with a certain delay. Fine. For importing the code into the PIC microcontroller, you need the software PICKit 3. So this is basically used for importing the code into the PICKit 3. Fine. Let's just open it. Once you will launch this program, you can see that the status LED starts blinking on, and here the window opens and the device is automatically detected that you have actually connected with it, and initially the memory is clear as well. Fine. Here you can see the different tabs. You can read the program memory, you can write the code into it, you can test your program, and finally you can also use the erase option for clearing the memory as well. Okay. In order to import the hex file, what I need to do, I will go to the file menu, import hex, and then I can select the file. This is test.hex file basically. So when I will click on it, you can see that the contents of the memory has been changed. Fine. Initially they were all 1111, but now the different codes have been written into it, ensuring that the program or the code has been imported into the memory. Fine. The next step is to write it. Sometimes you need to write it as well. Fine. Otherwise it's already written in the program memory, so you don't need to do it again. And now the next step is to verify the code. So when I will click on the verify, so it will actually test the code is written successfully. Now I will check on the development board either the code has been written correctly or not. So I will power it up, and here you can see that the LEDs are blinking. Fine. So I had written the code for blinking the particular LEDs of the port B. In this way, you can see that the code is imported into the PIC microcontroller memory. One thing more, here it automatically or gives you the erase option as well. So when I will click on it, you can see that the memory is erased and now there is no blinking of the LEDs. Fine. Thank you for watching.